Have you ever wondered why cement turns rock hard when mixed with water? I used to think cement was simply crushed stone, but after learning how it's made, I realised it's one of the most fascinating engineered materials ever created. Cement is made from about 80% limestone, 15% clay, and a small amount of iron ore. Its production can be summarised in three main stages: crushing, burning, and grinding. First, limestone, clay, and iron ore are mined and crushed into small, uniform pieces. These materials are then carefully measured and mixed before being ground into an ultrafine powder inside a giant ball mill. This powder is called raw meal, but it isn't cement yet and won't harden when mixed with water. The real transformation happens inside a massive rotary kiln. After being preheated, the raw meal enters the kiln, where temperatures reach about 1,400 degrees Celsius. At this extreme heat, the minerals undergo complex chemical reactions and fuse together, forming dark grey nodules, known as cement clinker, the key ingredient in cement. Once cooled, the clinker is mixed with a small amount of gypsum and ground into the fine powder we know as cement. The gypsum plays a vital role by slowing the setting process, giving workers enough time to transport, pour, and shape the material before it hardens. So why does cement become solid when water is added? The answer lies in a chemical process called hydration. When cement reacts with water, it forms strong crystalline compounds that bind everything together, creating an artificial stone. This reaction continues for several weeks, which is why freshly poured concrete must be kept moist during curing to achieve maximum strength. Although cement is the essential binding material, it is rarely used alone because pure cement can shrink and crack after hardening. Instead, it is combined with other materials for different construction purposes. The simplest mixture is mortar, made from cement, sand, and water. Mortar is commonly used for bricklaying, plastering, and tile installation, but it isn't strong enough for structural support. For buildings and infrastructure, engineers use concrete, which contains cement, sand, gravel, and water. Think of cement as the glue, sand as the filler, and gravel as the strong skeleton that carries heavy loads. Together, they create one of the world's most important construction materials. Choosing the right cement also matters. 32.5 grade cement is suitable for light construction and finishing work. 42.5 grade cement is the most common choice for homes and general construction because it provides an excellent balance of strength and cost. 52.5 grade cement offers much higher strength and is typically used for bridges, high-rise buildings, and demanding engineering projects. If the grade includes the number 2, it means the cement gains strength more quickly during the early curing period, making it ideal for fast-track construction. Concrete has its own strength grades. C20 is commonly used for sidewalks and simple foundations. C25 and C30 are widely used in residential buildings, while C35 and higher are designed for high-rise buildings, bridges, and heavy-duty structures where maximum strength is required. Now you know the secret behind cement. It's not just powdered stone, but a carefully engineered material that literally becomes artificial rock through chemistry. If you enjoyed learning how cement and concrete are really made, don't forget to like this video, subscribe to the channel, and turn on the notification bell for more fascinating manufacturing and engineering stories from around the world.